Good day.
Buenos días.
Servus und guten Tag. Hi everyone. We are happy and glad that you joined us for today's seminar about database upgrade internals.
We want you to reveal the mystery of upgrades and shed some light on this black box. We want you to become an upgrade champion after this webinar.
We hope that you will enjoy a lot of insights, secrets, tips and tricks. And our goal is to ensure that your next upgrade will be a walk in the park.
A few organizational things up front. At first, the slides. The slides are already available on the upgrade blog, mikedietrich.de.com/slides. Go to webinar 2021 and find the slides for today's seminar there. The seminar will be recorded as well. It takes approximately a week until the recording is finished and publicly visible. We will publish a link on the upgrade blog, mikedietrich.de.com/videos. And in addition, you will receive an email with the link as well. For today's seminar, we try to answer all your questions. Please make sure you use the Q&A, not the chat. So the Q&A is the forum where we try to answer all your questions coming up throughout the seminar. If we can't answer your questions, feel free to drop us an email afterwards. Email addresses at Oracle work always firstname.lastname@oracle.com. The seminar will take approximately 2 hours, and in between, in the middle, we'll do a 5-minute break. Then you can refresh yourself, you can refill your cups, your glasses, and so on. And then we will go on with more upgrade details. So now it's time for us to introduce ourselves.
This is Frederic Alvarez. He is a principal developer and part of our upgrade development team. He is also one of the masterminds behind AutoUpgrade, and he is really a wizard in Java. If you're into some geeky developer stuff, I suggest that you follow him on social media.
I'm very happy to introduce Daniel. So Daniel joined us over a year ago, and he's not only the principal product manager for cloud migrations, but as you will see today, Daniel is extremely firm also in every aspect of database upgrades and especially AutoUpgrade as well. So visit Daniel's blog to learn the newest about database upgrades, about migrations, dohdatabase.com, and follow Daniel on Twitter on dohdatabase.
I am sure you already know who Mike is. He is an upgrade superstar. Mike is the go-to person when you have inquiries about database upgrades and migration-related projects. He is very active on social networks like Twitter and LinkedIn, but also he is an avid blogger. If you are into IT, database upgrades, migrations, DB patches, and such, I recommend you to give it a shot to his blog.
Database upgrade basics. And first question, why do you want to upgrade? Do you upgrade because of the cool features in 19c? Some of you do. Do you upgrade because of free pluggable databases included even in standard edition license? Some do, but for most customers, the main driver is this slide here. Lifetime support policy. If you're on 11.204, and I know some of you are, there's no bug fixing support for 11.204 anymore unless you have signed an extra cost agreement called market-driven support. For most people, 11.204, even if you had a ULA or a pooler where the red period here, the extended support is included automatically, bug fixing support now is over. Game over for 11.204, you have to move forward. 12.102, it's also in the red period, extra cost thing. Or you have a ULA or a pooler agreement and you can include it at no extra cost. But even when you look at 12.102, it's a year and a bit left. So you must move now. It's time to move. And I know that a lot of production databases out there are on 12.102. For those who are on 12.201, the premier support, the black period, ended on 30th of November 2020. But as many of you are on 12.201, we added an extra period at no extra cost called limited error correction support for severity 1 bug fixes, security fixes. So we are releasing release updates, we are releasing single patches, we are releasing merge patches on top for critical issues only for 12.201. Still, also there's less than a year left, or actually it's a year and a bit now until end of March 2022, and you should start testing going to 19C. For 18C, you see the period is close to being over, and there's no extended support. That's very important to mention. So 19C is the release you all will target. But why not 21? And the explanation is in that slide here. 19C is the long-term support release. And a long-term support release has always 5 years of premium support at least, plus an additional minimum of 3 years extended support. 19C is such a release. And the release coming after 19C, 21C, is an innovation release. Innovation releases have a very short support time frame. So an innovation release has a minimum of 2 years and absolutely no extended support. So if you would go live on 21C, that means you have to be prepared to do the next upgrade very, very quickly. And when you have a bigger estate, like hundreds of thousands of databases, then you certainly won't target 21C. You may give 21C to your developers to develop a new application stack to do your early testing. It's fine for that, but be prepared. No extended support means at some point the support period is over, so you have to move very quickly. That means for your production estate, you go to 19C, and once you're on 19C, you will go to the next long-term support release from there. This MOS note here on the slide 742060.1 has all these dates and the definitions of long-term and innovation release. And whenever you would like to find out, is this release available on my platform, or when has it become available, or how long will it be supported, or are there any extra restrictions, you find it in that note. And this is also why we call it the single source of truth. So 12.201, currently under limited error correction support, you have until end of March 2022. You must go forward now to 19C. A year passes very quickly, believe me. 18C, you have just a few months left from now on. It ends, I think, end of June 2021. So move forward now. There's absolutely no extended support available and no chance for extended support. So 19C. And 21C here on the slide already, in the mid of 2023, the support will end. So 2 years and a bit from now on. Use this for application development, but don't use it for your production estate. That's it for a start. Now let us clarify why we need an extra seminar for database upgrade. Isn't upgrade so simple? Why do these guys need to take 2 hours about database upgrade internals? Let's start here with why upgrade is so different. And first of all, one of the questions Daniel, Fred, I receive every so often is, how long will my upgrade take? Or how long will my customer's upgrade take? And we certainly could answer always 42 minutes, but we don't, because there's no clear algorithm to tell you how long your upgrade will take. During a database upgrade, we don't touch your data normally. There are very rare exceptions, like, for instance, a text index needs to be rebuilt. Then we need to touch that index. But this doesn't happen so often. And normally, data remains untouched. The main driver for the upgrade duration is the number of installed components. So when you look into CDB_registry or DBA_registry, the more components you find in there, the longer your upgrade will take. And not only because the component upgrades are mainly not parallelized. The main driver is that some of the components take pretty long, actually. So here is an example on this screenshot. You see an upgrade with, I would guess, 10 components, and it takes 52 minutes. If I go in and remove some of the components I don't use, like, for instance, multimedia here and the enterprise manager, the upgrade duration shrinks to 30 minutes. So this is your main handle to make an upgrade run faster. Another option is the size and the complexity of the dictionary, but there is not much you can do. You can't remove like 20,000 stored procedures. You can sometimes reduce a bit of amount. There are cases, and this is why we have some feature version combinations here as third bullet point on the slide. Let's say in 11.2, we had a case where the synopsis, the incremental statistics information in a dictionary, got first of all partitioned with one upgrade, and in the next upgrade to 11.204, the partitioning layout got changed. So if you had like 500 gigabytes of incremental stats in your dictionary, that took quite a while. And in this case, it was more wise to just truncate that information beforehand. So also another good example, Oracle eBusiness Suite. If you look into OBJ dollar and you count the objects in an EBS database or an SAP system, you find a lot of objects. And when we adjust, when we change something in the dictionary, when we have to mow now through dictionary tables, the more information is there, the longer certain actions may take. But main driver is really the components. CPU speed, disk speed, that can influence the upgrade, and also SGA and PGA. Daniel will show you some cool examples on that later on. But main driver, components. When you want to remove components, do this before the upgrade. This is a strong recommendation. It not only is easier in many cases, but also, of course, you save upgrade downtime. So remove components beforehand. Look it up on the upgrade blog. I tried to put everything together in pieces because it's spread out in the documentation. Some components are not even covered in the documentation in terms of removal and have Moz notes instead. So it's a mix where you find the information. The upgrade blog has everything for you if you want to remove components. Classical examples are you go from 11.204 to 19c. You have a database control repository for Enterprise Manager. That does not exist anymore with 12.1. Remove it beforehand. Saves you a few minutes of upgrade duration. Another typical example, Oracle Multimedia. It's still there as sort of component in 19c, but really not useful because the API has been removed. Remove it beforehand, saves you upgrade downtime, makes your life easier. And the side effect of having less components is also some security fixes on a quarterly patch basis are just targeting certain components. So if you don't have that components, and a typical example is Java VM, the OJVM, then you don't care about any security flaws if it's just not in your database. And in addition, you save also upgrade duration downtime. Don't take this as a recommendation to remove and rip out everything of your database, because if tomorrow a developer comes to you and says, hey, we need that, then you see yourself reinstalling it again. And some of the components require also a bit of downtime when you install or deinstall them. But please take this as a, I would say, a fact, less components, faster upgrades. Why else is upgrade so different? Upgrade is a brutal DDL workload. So when we look, and our teammate Cindy did a quick check on 11.204 to 19c non-CDB upgrade. And we do 2,500 alter statements, so mostly alter tables, but also types, users, 16,500 create or replaces for views, types, synonyms, procedures, and so on. So be aware that happens mostly in system table space. Also, a few of these things are in sysorgs, but it's mostly a brutal DDL workload in the system table space. And it gets even more challenging if you do this now for 50 PDBs at the same time, and they all hammer in the master dictionary of the CDB dollar root. So be aware, it's a very unique, very, very different workload. Then during database upgrade, the database is in upgrade mode. And the upgrade mode is a very special mode. Or to be precise, the database, when you look in the alert log, there's an alter database open migrate. And with that command, a lot of things happen in the background, things which are not visible to you. For instance, we suppress expected errors. We have a long list of conditional suppressed errors. So we say, okay, if that object type gets changed and this error code is coming, then we don't signal an error because we know the upgrade scripts are rerunnable. So we can restart and restart him over and over again. And in order not to run in errors when we do a create or replace of things and create table where the table is already there, we suppress certain errors. SysDBA privilege is required, and in addition, we turn off a lot of functionality. So this snippet is taken from the alert log from an old upgrade. Today, you don't see this anymore because there was a fix which had nothing to do with upgrade, but now these messages are all suppressed. You don't see them anymore. But we turn off system triggers, we turn off undo, auto-tune, undo retention gets set to a specific value. We turn off advanced queuing, and so on and so on. Recycle bin is off, and much, much more. So this happens in the background. We don't show you that, but trust us, this happens when you start up your database in upgrade mode. And the reason why this happens in the background is to prevent any unexpected things and creates like a sandbox mode for the database upgrade to have no trouble with starting jobs in the background or whatever. Now, it's also ensuring that we have exclusive access. So cluster database is false when we upgrade, no system triggers, no resource manager, unfortunately also no AWR. This is a bit of a tricky piece because if we want to monitor upgrade performance precisely, we have to use other techniques. We can't rely on AWR data because the AWR packages are invalid during upgrade and they don't work. What happens during a database upgrade? So in RDBMS admin directory, you find a lot of scripts. And basically what's happening during an upgrade, we run upgrade scripts. And the upgrade scripts, for instance, here's an example. They start with C, so C18, I18. And you can look in these scripts, they're all open and you see what gets created or what gets altered. And then we have install scripts. And the install scripts are catalog and cutproc, of course, some others as well, but also an A script, which after catalog and cutproc have been completed, adds extra things we can just add at this stage when catalog and cutproc had been completed.
Now that we have scratched the surface, let's talk about parallel upgrade. When you upgrade a non-CDB database, the upgrade engine will use a number of parallel processes. For non-CDB upgrades, the default is 4, but you can change it all the way up to 8. In the following example, I'll be using 2 parallel processes, which is equal to calling DB upgrade with minus lowercase n and then 2. When you start the upgrade, there is a number of phases that the upgrade has to go through. Each of the phases contains a number of scripts. And in my example, I have 2 workers that are working on the upgrade. And in phase number 1, each of the worker will work separately on one of the scripts. Before the workers can proceed to the next phase, all the scripts in one phase has to be completed, which means that while the workers are working on phase 1, none of the workers can proceed to phase 2 until all of the workers are done with phase number 1. Now the workers are proceeding to the next phase. And in a little while, worker 1 is done and will move on to script number 3. But now worker 2 is finished and has nothing to do. There are no more scripts in this phase, so now worker 2 is idle. Now, worker 1 moves on to the next phase, but in this phase, there is only one script, so worker 2 is still idle. So, even though there are some parallel options during an upgrade, as you can see, in some situations, some of the workers are idle because there are no more scripts to process in a given phase. Or it could be that one phase is designed to be serial. So this means that by adding parallel processes, you shouldn't expect it to scale linear. If you add more parallel processes, it will be faster, but it won't scale linear. And this has also to do with contention. Even though you add more parallel processes, a lot of the workers has to go into the same part of the dictionary, into the same part of the shared pool. So by adding more workers, by adding more parallel processes, we start to see more contention. If you look at a container database, it's kind of similar. You start by assigning a number of parallel processes that work on the entire upgrade. The maximum is actually unlimited, but it defaults to the CPU count in your system. In the following, I'll be working with 4 parallel processes in total, and for a container database, that is equal to calling DB-upgrade with minus lowercase n and then 4. In addition to that, when the upgrade has to work on each individual PDB, it'll use a number of parallel processes, and it'll take it from the overall count of parallel processes. For a container database, the upgrade of PDBs goes with a default of 2, and you can bump it up to 8 if you want. But as with a non-CDB upgrade, the more workers you add, the more contention you start to see in the dictionary and, for instance, shared pool. The number of parallel processes that are assigned to each individual PDB is controlled with the uppercase n parameter. And in the following example, I'll set that to 2. So the total number of processes, lowercase n, if you divide that by the number of processes that are assigned to each individual PDB, you can find out how many individual PDBs that are upgraded simultaneously. In my case, it's 4 divided by 2. So imagine this example. I'm calling DB-upgrade, lowercase n 4, uppercase n 2, meaning a total of 4 processors are in use, and I'll use 2 for each. What happens first is that CDB$root gets upgraded. And the upgrade of CDB$root or any other container, any other PDB is actually similar to how you do non-CDB upgrades. There is a set of phases which contains a set of scripts. Once CDB$root has been upgraded, the engine can then continue on upgrading PDB$seed and PDB1, the user PDB, in this case in my single tenant upgrade. So this means that non-CDB upgrades are always faster than single tenant upgrades. Because in non-CDB upgrades, you only have one dictionary to upgrade, whereas in a single tenant database, you first have to upgrade CDB$root and then move on with PDB seed and the user PDB. In contrast, if you look at a multi-tenant upgrade, you have not just one PDB, but a whole number of PDBs. First, CDB$root gets upgraded alone. When that has completed, the upgrade engine moves on with PDB$seed and the first user PDB. When those two are done, the upgrade continues with the next PDBs and the next until all PDBs has been upgraded. If you want to scale your multi-tenant upgrades, you have to increase the number of PDBs that gets upgraded simultaneously. And you get much better scalability by adding more PDBs than by adding more parallel processes per PDB, because then you start to see contention inside each individual PDB. And in addition to that, we have Unplug plug upgrades. Our PDB, PDB1, is currently in a lower release container database, and we want to upgrade that to a higher release. So we start by creating a new container database on the higher release. Next, we can unplug the PDB from the lower release, plug it into the higher release, and then upgrade that PDB only. So Unplug plug upgrades are always faster than a non-CDB upgrade. The dictionary in a PDB is slightly smaller than in a non-CDB, but also during upgrade, the database is restarted multiple times. When you restart a non-CDB database, you have to take down the entire instance, stop all the background processes and release the instance memory, and then restart. Whereas a restart of a PDB is much faster, and it typically takes only a few seconds. In addition, an Unplug plug upgrade is always faster than a single tenant or a multi-tenant upgrade, because you only have to upgrade that specific PDB, and you don't have to upgrade CDB$root, seed, and all the other user PDBs. So performance-wise, there is really a good benefit of using Unplug plug upgrades. But now I'll leave it to Frederick to talk more about the upgrade internals.
Thank you, Daniel. Now let's dig into a little bit more into what actually is a database upgrade. As you may already know, a relational database is backed up by something called the data dictionary. This dictionary contains the definition for every object on the database, and you can see it as the metadata. When we upgrade, we are executing a set of scripts that will either create, modify, or drop dictionary objects that will add performance improvements, better security, or add new features. Each script is carefully created by us, and each one of them is executed on a very specific order. The upgrade is split into something that we have denominated upgrade phases, having now 108. The total number of scripts run will depend on the components installed on the database. We first start by recreating the very basic structure of the database, like the actual SQL core, to finish with the packages used by the database components like Java, Spatial, Apex, and so on. Once we have finished with the upgrade of every component, we consider that the database upgrade has finished. You can find a file called upgsummary.log that will show you what is the actual time that it took to upgrade every component. We invest a lot of time looking for ways to decrease the total amount of minutes that it takes to operate a database, because we understand that every minute of a database being offline matters. That is why we have found ways to execute some parts of the upgrade in parallel. If you take a look to the upgrade log, you will find that some of the scripts run for every component are run in parallel and others are run in serial fashion. This is still an ongoing research area for us at Oracle, and although we have done a great progress, we are always looking for new ways to execute the scripts in a way that they will take less time to run. Every upgrade, around 1.5 million of SQL statements are run. Every release, we perform an analysis over the statements that are run to understand what are the statements that are taking the most time and see how we can improve them. So here you are seeing how the actual timing for each statement run during the upgrade looks like. Now, how do you think that the CDB upgrade process works? Yes, you are right. It is about the same thing, but this time the tasks previously described are executed for every container on the CDB. This means that we are going to perform the upgrade for CDB root, PDB seed, and the rest of the PDBs. And as you can imagine, the plot for the timings will be the same, but this time we will get one for every container.
Wow, that was a lot of detail and a lot of numbers. We'll stick with the numbers, but I'll take you a little up and we'll have a look at an upgrade from a bird's eye perspective. We told you previously that during an upgrade, the CPU is a vital resource, and it means much more to the upgrade performance than adding more memory or getting faster disks. We made an experiment. We provisioned a bare metal system in OCI. It had 16 OCPUs, a lot of memories, and super fast NVMe disks. We created a container database with 52 PDBs. CPU count was set to 32. 16 OCPUs means 32 CPU count. 100 GB of memory for the instance. The database had all 17 components installed, and we tried an upgrade from 12.102 to 19. This is what happened. This is a graph of the CPU utilization for the 4 hours and 8 minutes that it took for the upgrade to complete. Since CPU is a vital resource, we would love to see it used as much as possible. So you could actually argue that everything above the red line is waste, unused potential. And ideally, the utilization should look something like this, constantly at 80 or 90%. But that's not realistic, because we learned previously that some of the phases in the upgrade is serial, and sometimes some of the workers are idle because they're waiting for the next phase to start. First, we have the pre-upgrade checks and fix-ups. One of the recommendations that we give you is that you should gather fixed object and dictionary statistics in advance of the upgrade, so you don't have to spend precious downtime on gathering statistics. If I follow that advice, I end up with something like this. It saves me 12 minutes on the upgrade by gathering dictionary and fixed object statistics in advance. The CPU utilization is still, I would say, average, but I can save some time by gathering stats in advance. The next phase is upgrade of CDB $root. The recommendations I can give you there is to try to remove some of the components, but that might actually be hard, at least in CDB $root, because you have to remember that CDB $root has to be a superset of the amount of components that you have in all the user PDBs. If you have one component in use in one of your PDBs, it has to be installed in PDB $root. In addition to that, you can ensure that as much parallel processes are assigned to the upgrade of CDB $root as possible. We learned previously that it's 8. And when you use AutoUpgrade for the upgrade, it'll automatically ensure that 8 parallel processes are used for the CDB $root upgrade. But we can still try to see what happens when we remove some of the components from CDB $root. And you will end up with something like this. In the lower graph, we redid the same upgrade, but we removed all the components except 3. So there's a dramatic effect on the upgrade runtime, and it knocked off 13 minutes. So that's quite good to consider, I would say. In the next phase, we are upgrading PDB $seed and all of the user PDBs. I told you previously that you should scale a multi-tenant upgrade by allowing more PDBs to be upgraded at the same time. And you can see here from the CPU utilization that even though it's running with 32 parallel processes, I would say it's only average, and it's probably around 50% or so. So there's really a lot of unused potential. So let's see what happens when we change the total amount of parallel processes that are available for the upgrade from the default of 32 and now into 54. And the effect is dramatic, I would say. We get much better CPU utilization on the lower graph, where we have 54 parallel processes, and it saves 26 minutes on the upgrade runtime. So we are actually overloading the system here. We are allowing more parallel processes to be used by the upgrade because we know that sometimes some of the parallel processes are idle, either because it's a serial phase or because it's waiting for other workers or parallel processes to finish. So I would say you can actually overload your database upgrade by allowing more parallel processes than you have CPUs in your system. In addition to that, you can also look at whether you can remove components from your PDBs. I did the same here, and I removed all components from the database except 3. The overall runtime of my upgrade saved me 48 minutes. And if you include the 30 minutes it saved on CDB $root, I could actually save an hour, almost 25% of the entire upgrade by removing components from the database. And the last phase of the upgrade is the post-upgrade checks, which includes the PL SQL recompilation, the UTLRP scripts. And that's actually very good parallelized already. So there's really not much to gain in this phase. And the only recommendation I could give you is to postpone the time zone file upgrade. So the conclusion of this little experiment is that you should gather statistics in advance. You should allow more PDBs per cycle by overloading your upgrade, I would say. You should allow more parallel processes to be used than you have CPUs in your system. How much? It depends. Each database upgrade is really different. So you have to go home and try it on your own databases to find a number that makes sense to you. And finally, really, you should get rid of those components in your database that are not in use. And you saw the effect on the numbers here. Almost 25% of the upgrade could be saved by lowering the amount of components in the databases. Now that we've talked so much about upgrade so far, let's see how you can actually do an upgrade.
Thank you, Daniel. How do you upgrade? Successful database upgrade, very straightforward. You grab 19c software, you get always 19.3.0. Then you add the newest release update, 19.10. If you have OJVM, also the newest OJVM PSU. And then you download the newest AutoUpgrade, and we will show you later why you need to download the newest. So this is the upgrade, the install part, the patching part. That's always straightforward. You will invest more time, of course, into the performance testing, the performance evaluation part, which starts with SQL Plan Management, a free Enterprise Edition feature, SPM. And in addition, you can use SQL Tuning Advisor, you can use the SQL Performance Analyzer, part of real application testing, and some other techniques and tools to ensure performance stability. But we won't cover that. We covered this part in a previous seminar already. Today, we would like to focus on upgrade only. And first question is, which release do I have to be on in order to upgrade directly to 19c? And this slide here applies to upgrades. If you intend to migrate with data pump, with transportable table spaces, another technique, unload your data, whatever, you don't care. But if you do the database upgrade, as we would like to show you today, then you have to be at least on 11.204. You can be on 12.102, on 12.201, or on 18c, and then you can go directly to 19c. But what if you have an older release? I receive emails every week, customers or colleagues asking for 11.203. What do you do then? So at first, in the upgrade guide, you find what is supported right now, direct upgrades. But what do you do with these older releases? Then often the wisest approach is to use an intermediate release. So while we would recommend you to jump always to the newest possible, so in the case of 11.203, I think to remember the newest you could upgrade to was 12.102. And then from 12.102, you can go to 19c. So we call this a double hop. Or in very old cases, like with 9.2, you may have to do triple hops, actually. But sometimes you hit also restrictions. For instance, 12.102 may not be supported on the operating system you have on the server you host the 11.203 database on. So in that case, you may go to a lower version release, maybe to 11.204, because then you can also go onward. So it depends. There's no clear answer, but usually our recommendation would be go to the newest possible, because most likely, if there were issues before, we fixed them in a newer one already.
If you are close to performing a database upgrade, it is a good time for you to learn about the AutoUpgrade, which is not the only recommended way to go, but is the actual tool created by the database upgrade team at Oracle. As of 2021, the AutoUpgrade has 5 execution modes, 38 single parameters, and 15 internal customizable parameters that can be used and combined to cover most upgrade scenarios. Why so many? Because we have heard the feedback from you, and we are always reinventing the tool to make it better, to make it faster, and to make it more flexible. We know that each database is subject to different conditions because each company has different policies. That's why we have added into the AutoUpgrade advanced SP file management, advanced network file support, advanced architectural change support. This is, you can use AutoUpgrade to change your database from non-CD to PDB. We have added support for faster restoration based on GRP. The AutoUpgrade also has full upgrade support for rack on POSIX systems. And we work a lot to make it fully resumable. This is, in case of something bad happens and the process dies, you can continue from where it left without having to worry about what happened. Also, the AutoUpgrade supports upgrades in place, and also it's very capable because you can customize what kind of fix-ups for pre and post-upgrade runs because you can enable or disable them from the configuration file. As well, you can run not only one but multiple database upgrades using the same configuration file and the same AutoUpgrade instance process. One of the most interesting parts of the tool is that it has the fastest development cycle. And when I say the fastest development cycle, I mean we work very, very, very fast, making and hearing back and applying changes from the customers. Even though the AutoUpgrade is a very powerful tool, you just need to learn 3 steps before you can start using it right away. Let's recall that the AutoUpgrade is a multi-platform and multi-version tool. This is, you can use the same tool and the same version to perform an upgrade from different source versions towards different target versions. With the latest version of the AutoUpgrade, you can perform upgrade from sources such as 11.204 until version 19. Once you have selected your source database, you just need to download the tool. This is, you just need to enter to the most node listed here, download the latest version of the jar file, which is just a file of less than 3 megabytes, create a sample configuration file, which is just a plain text file, and it should contain as minimum as these 3 lines of text. It will have a source home, target home, and the SID. Once you have defined these 3 parameters in the configuration file, you just need to trigger the deploy. And this is, you just need to run the java -jar AutoUpgrade.jar -config, the path to your configuration file, followed by the deploy mode. After that, you just need to wait a few minutes and you will have your database upgraded, and that's it. In the latest version of the tool, you can perform upgrades towards version 12.201, 18, 19, 21, and any other feature release. The overall AutoUpgrade execution workflow can be depicted into 3 major areas. We have some tasks that run before the upgrade, we have the actual upgrade, and some tasks that run after the upgrade. In the area before the upgrade, we have some user-defined tasks. These are some tasks that can be configured in the user configuration file, and the AutoUpgrade will execute them before starting the actual upgrade. We also have some system checks. These are some checks that we run before the upgrade and that will ensure that the database and the operating system in general has the resources and has the conditions to have and to ensure that the upgrade will succeed. And finally, we have the database checks. These database checks will also ensure that the database is on a healthy state before performing the actual check and the actual upgrade. Once these checks have finished, we will proceed to executing the actual upgrade. And after we have finished the upgrade, we will proceed to the after upgrade tasks, in which we will find the after upgrade system tasks, such as copying network files. Then we will proceed to the after upgrade checks, like the time zone upgrade, taking stats and recompiling objects. And finally, we will execute the user-defined tasks. These are optional tasks that can be provided into the user configuration file, and that the AutoUpgrade will execute after everything has finished. One of the most complex parts of the process is the work done before the upgrade. This is because we need to ensure that the database is in a proper state before the upgrade. That's why we have invested a lot of time creating something that we call the pre-upgrade checks. These checks are small execution units that will help us to check a given specific condition on the database and will let us know if something needs to be changed. So we have 4 major groups for this kind of checks. In the first group, we have the components checks that will help us to ensure that the components are on a proper condition, are valid, and or detect if they shouldn't be there, like the case of Enterprise Manager, which was removed, and let you know if this can be done before the upgrade to save time during the actual upgrade. Also, we have checks for detecting configurations that might affect the auto upgrade of the upgrade process itself, like detecting if, for example, you don't have the compatible parameter set, and or, for instance, the auto login is not enabled for the wallet. We also have another set of checks which are related to the amount of space used by some components, or to detect if we will require some additional space during or after the upgrade, like detecting the amount of free space on your table spaces for sys or sysaugs, detecting if you have, for example, a temporary table space without a temp file associated, and also another miscellaneous set of checks that will check if, for instance, you have a time zone version higher than the target version of the version that you are going to upgrade to. Currently, in the AutoUpgrade, we have over 115 before upgrade checks, 14 system checks, and 19 checks for after the upgrade, and 10 system checks for after the upgrade. The AutoUpgrade supports architectures for CDB and non-CDB, plus also supports all the operating systems supported by Oracle, including all database editions, like Standard Edition and Enterprise Edition. Plus, it also works on single instance and rack databases. With the AutoUpgrade, you can perform upgrades from all the supported versions, starting from 11.2.4 and newer versions, and you can upgrade to versions starting from 12.2.01 with the patch of 2019, and also towards versions 18.5 that already includes the patch of 2019, or 2.19.3 or newer versions. Besides the command line, you also have the option to perform the upgrade using the database upgrade assistant. However, this is not our choice, and you need to be aware that the tool is not fully resumable, which means that if something bad happens and you have a problem during the upgrade, you might have problems finishing the upgrade.
Thanks, Fred. Now, forget command line upgrade, forget the UUA. It's time for more auto upgrade. You probably already heard this, but always download the latest version of AutoUpgrade from our Oracle support. We push out new versions as often as we can. You can use AutoUpgrade with the version option to show the version of AutoUpgrade that you're using. And you can compare that with the information you can find about the latest release on My Oracle support to see whether or not you should upgrade the AutoUpgrade that you're using. When you've done that, when you downloaded or ensured that you're using the latest version, you create a configuration file. If you don't want to create your own, you can create a sample configuration file and use that as a basis for your configuration file. Next, you analyze the database to ensure that it's eligible for upgrade. When the analyze is complete, you can find a summary report either in HTML or in a log file. The log file might look something like this. And in the bottom, you can see that this specific database is ready to be upgraded. There's nothing that you have to do yourself. You can also look in the HTML file to find similar information. And it even has a link to a pre-check report, which contains a lot more information about the database. In the upper part, we have some overall information about the database, including which components are installed. In the lower left section, we have information about each of the containers. We have all the issues grouped by severity. And in the lower right corner, you can get all the details about all the findings that we made in your database. All our log files, all our reports comes in HTML, text, and JSON, and some of them even also come in XML. Now it's time to upgrade the database, and you use the deploy mode for that. Once you've started AutoUpgrade, just sit back and relax, have a cup of coffee or tea, and wait. Or you can monitor it. Use the LSJ command to list the current jobs. If you want even more details, you can use the status command, which has so much information that it fits on 2 pages. After a while, the job completes, the upgrade has been made. Now you can use your database. all the post-upgrade checks has been executed by AutoUpgrade, there's really not much more for you to do. If you want to start AutoUpgrade in an easier way, you can do it in a one-liner by supplying some of the information as environment variables. In addition to that, you can use the config values option to put in all the parameters that you would normally put in your config file. You can specify them on the command line using the config values option.
Now that we have learned the essentials about the AutoUpgrade, let's take a look to the actual execution. You just need 10 minutes in order to become an AutoUpgrade hero. So we first start by downloading the latest version of the tool from the mouse. Then you just need to find out which are the actual instances that you want to operate. So in this case, we are going to grep to find the actual Oracle home of two PMON processes. So in this case, we are going to operate two databases, one 11.204 and one 18 version. After that, we are going to create a configuration file. For this, we will need to find the actual target version that we want to upgrade to. So we find out that on the Aura tab, and then we create the configuration file with the information that we just found. So to do so, we are going to use the option create sample file, which is an option of the AutoUpgrade. This will create a configuration file with some placeholder and blueprints that we can use to edit later on. So once the file has been created, we can open it up with our favorite editor and we can replace the files. One side note is that since we want to use the URP option for the restoration of the AutoUpgrade, we will need to enable the archive mode on both databases, DB11.204 and CDB18X. So after we have taken the parameters that we want from the sample file, our final configuration file will look like this. We save the changes and then we just execute the tool using the command java -jar AutoUpgrade.jar -config, the path to our file, then -mode deploy. So the tool will examine the configuration file, we perform the pre-checks, and then we just need to wait. And that's it. Just to gather some status from the tool, we can use the lsj command just to gather what's the current status. And that's it. After a few minutes, the upgrade will finish, and then we will have our databases upgraded and on version 19.
Oh my God, that was a lot of upgrading already. And we are halfway through. So now it's time for a 5-minute break, relax, and we make an announcement during the break regarding slide download and video replay. So see you then in 5 minutes. Thank you, Frederick. Now, AutoUpgrade advanced options. What else is there? What can you do with AutoUpgrade? How powerful is it? And let me start with a very simple thing here. With one config file, you can cover as many databases as you want. And what we use here is, in the first example, you see only one database, and you see the prefix, in this case, UPG1. And I can differ between different databases with different prefixes. So in the second file here, we cover more databases and we use different prefixes. You don't have to go with UPG1. You can use whatever you want. Mike, Hugo, Daniel, Fred, whatever is convenient for you, works for you. It could be also the database name. Whatever you want, you're free here. But you can cover hundreds and thousands of databases with one config file. Next option, you can also run the upgrade with the same config file on different servers. If you want to have one central upgrade config file for AutoUpgrade, you have this parameter upgrade node. And that means only if the node name matches what you described in upgrade node, that database will upgrade it. So when I execute here the AutoUpgrade with that config file on prod_server01, then the database covered with the prefix UPG1 won't be upgraded. It won't be even attempted to upgrade because the upgrade node doesn't match the actual node name of the server. But please be careful when specify the upgrade node. Normally, you would say localhost, or you just don't use the parameter. It's not needed. And then you avoid a pitfall here if you run AutoUpgrade locally and have an upgrade config file for each server separately. Then I think this is one of my favorite features because I use this by myself all the time, tweaking SP file parameters. So I can pass parameters onto AutoUpgrade. I can advise AutoUpgrade to set certain parameters either during the upgrade or after the upgrade. So for instance, Daniel will show you later an example where you can have processes parameters set higher in a multi-tenant environment. I set always a standard set of parameters when I upgrade databases to 19c. And some of the examples I mentioned here below, for instance, the most famous _cursor obsolete threshold, which needs to be set to 1024, different from the default. Or turning off SQL plan directives, which get created still in the background with _SQL plan directive management control 0. So I pass this on with add after upgrade p file. I can do this for single databases. So you see the prefix UPG1 or UPG2 used, but you can do this for all your databases with one parameter line, and then you use the prefix global. So when I use this file here with global add after upgrade p file, and I pass on this simple text file, then all my databases will get these parameters after the upgrade is completed. But you can also use del during upgrade or add during upgrade, for instance, for a higher processor setting, or delete after upgrade. So all that is possible, extremely powerful. I like this a lot, and it helps you also to create a standard set of parameters and get rid of all these wild creations of historical, nostalgic parameter collections. What I like also a lot is the shell script execution in AutoUpgrade. So what you could do is you could use before or after action. One of the first requests we received from a customer was, I need a script which shuts down my middleware stack on that server before upgrade and starts it up afterwards. So before action, you pass on a shell script. And of course, this shell script can call another shell script, and it can call another shell script. And that shell script can use a SQL script and call another SQL script. So you can stack. You can use it global or again on a per database basis. And we passed on also this option. You see it here with a red marked the Y. This means if the return code of the shell script executable is positive, yes, then we will go on. If that fails, AutoUpgrade will stop. This is to make sure, let's say I want to stop my application server stack and that fails, I certainly don't want the upgrade to proceed here. So if the return code is false, then it will stop here and the database won't be upgraded. You have permitted executions for shell scripts on Unix. On Windows, you have more variety. You can use batch, command, or PowerShell. Then we have guaranteed restore points. By default, AutoUpgrade writes a guaranteed restore point unless it's a standard edition 2 database. Then we give you a warning in the analyze phase and tell you, hey, take care. You need to make sure that you have a proper backup, which can be restored as well. The other option is restoration no. This is useful, first of all, when you just test. I use it quite often, or in case your database is in no archive log mode. Whether this is on purpose or just by accident, but if you have a database in no archive log mode and you don't set restoration no, then AutoUpgrade won't attempt to upgrade your database because it can't set a guaranteed restore point. By default, the guaranteed restore point will be kept. So when you upgrade, afterwards, AutoUpgrade tells you the name of the guaranteed restore point and you have to remove it manually. Now, I had customers asking, say, Mike, I tested the upgrade 20 times and I do the production upgrade in a night from Saturday to Sunday next week, but I don't want to log into the system on Sunday morning, 2 a.m. when the upgrade is completed, just to remove the guaranteed restore point. And I don't want to have it sitting there until Monday morning. How can I remove it automatically once the upgrade is successful? This is the trigger here. Is the upgrade successful? And you use the second red marked parameter here, drop GRP of the upgrade. Yes. Then once the upgrade is completed successfully, AutoUpgrade will remove the guaranteed restore point. And I had another question from a customer who said, Mike, can I ask AutoUpgrade to remove all these old parameters, these old underscores and events? I think we have some, they date back from the 9.2 days. But I started to discuss that internally and people were not convinced and not sure. I just want to go in and remove them just blindly. Oh, sure, remove underscore parameters, yes. And underscores and events will be removed. By default, of course, they will be kept. So we don't touch them. We just give you a warning in the analyze run that you have underscores and events set, and you may check them. But if you say, hey, I pull out the big sledgehammer, remove all of them, you can do that. Postpone the recompilation. That is also something which is in some cases quite useful. For instance, there are CPU architectures out there which give you a lot of virtual cores. So we had cases with 64 virtual cores, and then the recompilation hammers in with 128 parallel jobs, even though you may have only 8 real cores in the system. So you do a massive overload. And in such cases, it may be good to postpone the recompilation. So you use run utl underscore rp equals no, and then you postpone it, you recompile by yourself. You could also skip the time zone upgrade. We won't cover the time zone upgrade itself today in more detail, but you find already information on our blogs. If you want to skip the time zone upgrade, then you say time zone underscore upg equals no. There could be several reasons for doing that. First of all, you may decide that a time zone upgrade is not useful in your environment. Maybe your database is just acting in Germany and has no data from outside of Germany, and Germany follows the usual Middle European or Central European time. No reason for that. But you may be a telco operator, telco's billing system, and then it may be useful to adjust that. Another fact to skip the time zone upgrade could be that it, first of all, may take very long in some cases, and you would like to apply certain workarounds, or it could also be the case that you would like to downgrade afterwards. And time zone can't be downgraded. When you downgrade a database and you upgraded time zone, then you have to make sure that the source home where you upgraded from has the same time zone file in place. So be aware of that. There are some reasons, or it could be simply that you want to save some upgrade time and skip it by yourself. Advanced options, and this is extremely powerful. You can pass on also cutctl options. So cutctl is the parallel upgrade underneath the covers, and cutctl options here are, for instance, options to define the parallel degree and the parallel workers for a multi-tenant upgrade. Right now, only for CDBs, not for non-CDBs. This is coming later. So here with the -n lowercase parameter, you decide the total number of parallel processes overall. The minimum is 4. The maximum is unlimited. The default is at the moment the host's CPU count. We will change this to the CPU count of the database in the near future. And -n, this is the number of parallel workers per PDB. The minimum is 1, the maximum is 8, the default is 2. Daniel will show you some cool numbers later on and some graphs, how you can adjust those and what's possible with these parameters in a real multi-tenant environment with many, many PDBs. Usually the default of 2 is the most efficient one. That's why we set that default. And then we show you also how you can monitor the upgrade with LSJ and status-job. But AutoUpgrade writes also a state HTML file. And what you could do, and I like that a lot, is you can start a Python simple HTTP server in that directory, and it will display the output, or the input actually, not the output, of state HTML. You open just the browser, and you send it to localhost, and the port you defined here. So in my example from the box, it would be 8888 and not 8000, state HTML. I would like to show you that. Let me show you a quick demo here. AutoUpgrade, one single command. So what we do here is we have an AutoUpgrade on a config file. I run the analyze before. Now I use deploy. And with deploy, I upgrade all my databases. What databases do I upgrade here? You see I have 3 databases, FTX, UPGR, and DB12. I can, of course, query and say, status-job 103. What is the FTX database doing? Okay, it has dictionary objects. But I find it much cooler to monitor everything automatically. So what I do here, I go to the logs directory, and in the logs directory, we have the CFG tool logs, AutoUpgrade auto. And in this one, you see the state HTML. So what I do here is I start a Python simple HTTP server. That should be on all your Unix ports, on the more modern ones. And I send it here to port 8080, whatever port you define. In my browser, localhost, :8080 state HTML. And now it displays this file. I don't have to refresh. It just refreshes automatically. With every update in the file, the browser gets a refresh. So what we see here is the 3 databases. FTX has started the upgrade. UPGR is in prefix ups. DB12 is in the setup. The upgrades are a little bit deferred, so they don't hammer all at the same time. Now, let's kick them off and let's see what happens. So now all 3 databases are in upgrade mode. And don't worry that the last one, the DB12, is a bit cut. As in a minute, the browser focuses better. Now it's focusing. So we see FTX 39%, UPGR, and it counts up, FTX 46, and so on. I don't have to do anything. This happens absolutely automatic. And if you have more databases, this is so useful because you don't have to type all these commands. You just monitor that web page. Now they're on the post fix-ups phase. And even when you plug in, it just goes on because I want to plug them in. They are all now in the non-CDB to PDB state, stopped, finished, and all are finished now, everything plugged in. Only one file, one simple web page. That's a super cool feature. Now, on with you, Daniel.
Before we end this chapter, here's a little trick on how you can use the shell script's capabilities to gather fixed object statistics. It's very important that you gather fixed object statistics after a database upgrade, but it's also important that you don't do it right after upgrade. Why is that? Well, fixed object statistics are on those memory structures that gets populated when you use the database. For instance, there's a memory structure which represents the buffer cache. When we upgrade the database is restarted multiple times, meaning that the buffer cache doesn't look as it does after your representative workload. It might be smaller, there might be fewer items in the buffer cache, and so forth. So you should never gather fixed object stats after upgrade. So ask yourself, do you remember to gather fixed object statistics on your database after you've run a representative workload? If not, well, DBMS scheduler to the rescue. First, you create a SQL script which creates a scheduler job that executes DBMS stats gather fixed object stats in 7 days, sysdate plus 7. You can also set the auto drop option to true so the job is removed afterwards. Next, you create a shell script which executes catconpl, which then executes the SQL script in all of your PDBs, including CDB $root. Now in your configuration file, you tell AutoUpgrade that after the upgrade, it should run the shell script, which runs catconpl, which executes the SQL script, which then again creates a scheduler job, which in 7 days gathers fixed object statistics for you. So if you want to avoid having the situation where you forget to gather fixed object statistics, this is an easy way on how you can use the capabilities of AutoUpgrade together with the scheduler to do it in 7 days. Doing it 7 days from now might not be the best time to gather fixed object statistics, but I promise you, it's better than forgetting to run fixed object statistics or doing it right after the upgrade. Now we'll have a look at AutoUpgrade in a case-by-case basis. So we will look at various use cases for AutoUpgrade, and we'll start with Unplug upgrade. As you've already seen today, Unplug upgrades is a faster way of upgrading a database comparing to a full CDB upgrade. It's also more flexible because you just need downtime on one specific PDB and not the entire CDB. But there are some caveats when it comes to Unplug upgrades. Flashback database doesn't work across plugin operations, so you can't use Flashback database as your fallback mechanism. So I would recommend that you either log into refreshable PDBs or that you copy the data files before you do Unplug upgrades. This is an example of a configuration file where I'm doing an Unplug upgrade of PDB1. I have a small video here which shows how it works. This is my configuration file, and it's a very simple one. I have the SID of my source container database and the SID of my target container database. I also have listed that I want to do an Unplug upgrade of PDB1, and if I had more PDBs to upgrade, you could put them in a comma-separated list. And also, I specify the source and the target home. Now I run AutoUpgrade in Analyze mode to see whether the PDB is eligible for upgrade. Now I can check the status log file. It contains some basic information about the releases, where are the log files stored, and most importantly, I can see that there are no manual tasks that must be carried out. So I can start the upgrade with using deploy mode. I use LSJ to monitor the upgrade, and I can see that the PDB is currently at 0%. I can also use the status command to get much more information. I can see how far in the phases the upgrade has progressed. I can see where all the log files are stored. And I can also see that currently the PDB is 6% upgraded. After a while, the upgrade completes. I log into my target container database, and I can see that PDB1 is now upgraded. It's open in read-write mode and not restricted. So the PDB is now ready to be used in the new release. Super easy. As mentioned in the video, you can specify multiple PDBs for Unplug upgrade by using a comma-separated list. You can even rename a PDB and give it a new name in the target CDB. In this case, I'm renaming my PDB from PDB1 to sales. Also, I can decide whether or not I want to copy the data files when I plug it into the target container database. This obviously requires twice the amount of disk space, and it takes time to copy the data files. But if you want to have an easy way of falling back the upgrade, then you have to copy the data files before you do the Unplug upgrade. Remember that I previously told you that you cannot flashback a plugin operation, so copying the data file is actually the only option of having a good fallback mechanism. In our current release, AutoUpgrade doesn't work on DataGuard when you do Unplug upgrades, and we don't support TDE yet. It's in the works. For your reference, I've included here a link to a blog post with much more detailed information about what happens when you do Unplug upgrades with AutoUpgrade. Next on the list, we have AutoUpgrade and DataGuard. When you have DataGuard and you upgrade your database with AutoUpgrade, it'll automatically detect the presence of DataGuard. It works whether you have broker-managed or manually configured DataGuard. And AutoUpgrade will take care of everything on the primary database, but you yourself has to take care of the standby database. I have here a little video that shows how you can upgrade with AutoUpgrade and DataGuard. My database is called prod, and prod 1 and prod 2 is running on the primary and on the standby host. I'm connected to BM1, which is the primary host. I log in to DataGuard CLI to the primary database. And as you can see here, prod 1 is my primary, prod 2 is my physical standby database. Now I switch to my standby host. I log into the standby database, and I query read-all parameter for the location of the broker configuration files. And I then generate commands so I can copy the files out of the Oracle home and into a temporary location. Now I stop the standby database, and I disable it just to be sure. And finally, I can use the commands to copy my broker configuration files. Now it's time to upgrade the primary database. I'm connected to BM1, the primary host, and I have a look at my AutoUpgrade configuration file. It's very simple. I only have the SID of my database and the source and target Oracle homes. Now I start AutoUpgrade and I specify my configuration file and I run it in deploy mode. And here I'm speeding up so we don't have to sit and wait for the upgrade to complete. After a while, AutoUpgrade tells me that job 100 completed and the database has been upgraded. And it even prints out commands that I can use in DataGuard CLI later on to re-enable read-o transport. Now I want to bring my standby database in sync with my primary database. So I connect to the standby host, and then I copy in my network files into the new Oracle home. And I also copy in my SP file and password file. And finally, I copy in the broker configuration files. Now I can upgrade the GI configuration and tells Clusterware to start the database in the new Oracle home. I ensure that it starts in mount mode as a physical standby. I re-enable the database, and I finally start it. Now back on the primary host. I connect to the primary database using DataGuard CLI. And then I set transport on. Primary database is now shipping the redo to the standby database. I show configuration, and I can see here that there is a warning. I show the details of prod 1, the primary, intended state transport on, it's shipping redo to the standby database. So far, so good. So let's have a look at the standby database. You can see here that there is a warning because there is apply lag, but that's actually expected because we shut down the standby database while we did the upgrade of the primary database. As the standby database catches up, you'll see that the apply lag decreases until it eventually has fully caught up with the primary database. And when that happens, the standby database has now been implicitly upgraded via the redo that comes from the primary database. No further apply lag. Everything's good. So let's test that my data guard environment still works. I use the validate command on my primary database. It reports that the primary database is ready for switchover. I do the same on my standby database, and it too reports that it's ready for switchover. So let's try it out. Let's do a switchover to my standby database. It takes a little while for the switchover to complete. But there you have it. Switchover succeeded. New primary is brought to. So AutoUpgrade can easily handle a situation where you have a standby database and it does some of the work for you. Doing a switchover after a database upgrade is actually a really good way of ensuring that everything still works. You will not be allowed to perform a switchover if there is apply lag between the two, if there's something wrong in your data guard setup. You can only do a switchover when the standby database is in sync. There is another approach to what I've shown you here, and that's the MAA approach, the maximum availability architecture. And those guys are really keen on having as little downtime as possible. So their recommendation is to keep the standby database online during the upgrade. This allows for faster go live right after the upgrade because you don't have to wait until the standby database catches up with the primary database because it does so while the database is being upgraded. So first you move the standby database to the new Oracle home and you do it before the upgrade. And you keep redo transport and redo apply on during the upgrade. And that will ensure that the standby database gets upgraded together with the primary database because redo keeps being transported and applied on the standby database. So this is another way, another approach that you can use. And which approach you use is, I would say, more a matter of personal preference. Each of them are equally good with their pros and cons. So you decide. Mike, will you take it from here?
AutoUpgrade to a new server. Another case. So you may have asked yourself, can I use AutoUpgrade also when I go to a new server? Or does it has to happen all on the same server? And of course, we knew that this case is very important, especially if you get a hardware refresh, as many of you do, together with a database upgrade. And the concept is very straightforward. At first, you run AutoUpgrade with -mode analyze on the source server. Then you also run, when your downtime arrives, -mode fix-ups on the source server. Then you shut down or restore your database plus the config files to the target server. This is not done by AutoUpgrade. You can also do this with a physical standby. So you create a physical standby and then you don't have to shuffle around your data files, your config, your redo logs anymore. Then you start up your database on the new server in upgrade mode, and then you run AutoUpgrade with -mode upgrade. We cover this also on the upgrade blog, and this is how it works step by step. So on the source server, you see that I have a source and a target home. This is a requirement, but no worries. You don't need the target home on that server. It's just more or less a placeholder for AutoUpgrade. And you specify the SID. Then you run mode analyze, mode fix-ups, you shut down immediate, you copy everything over. On the target server, what you prepared already is you updated etc ORA tab, and you prepared also your network admin files. Then you start up your database in upgrade mode once everything is received, including SP file and password file. And you trigger AutoUpgrade, and from there on with minus mode upgrade. And here you can use a dummy source home because your source home is not there. So I set it to a /tmp here. Important is the target home. This has to match. And then AutoUpgrade completes the upgrade of the database on the target server. Another thing we would like to highlight here is you can also use AutoUpgrade without upgrading, just to plug in. So you have upgraded already to 19c. You still can use AutoUpgrade to plug in your non-CDB and let it become a PDB. The only thing you need to do beforehand, you need to create a container database if you don't have any yet. So what you do is, in this situation, your non-CDB has been upgraded already to the target version, ideally to 19c. We need a config file. You see source and target home are identical here. I specify the SID of my non-CDB. And in addition, I specify the target CDB. This is the CDB which exists on my server already. And into this one, I want my non-CDB to be plugged in. And then I start AutoUpgrade with minus mode deploy on that config file. And AutoUpgrade won't do a database upgrade. It will recognize, hey, this database is upgraded. Yeah, but it should be plugged in. And of course, you can use also the additional parameters to rename your non-CDB to a different name, PDB, or you can use copy option, whatever. This is a super cool feature, works absolutely smoothly, and I used it quite a bit already. Now, this brings me directly to the next section. What if? What if something goes wrong? So tips and tricks and workarounds. And first one, and this is a common question we receive, what if your session is lost? So you start AutoUpgrade, and at some point, I had this also with my system here, it reboots. You lose your X-term, what do you do then? So good thing is, upgrade is fully resumable, and AutoUpgrade, of course, is fully resumable as well. And you restart it simply using the same parameter on the command line. The previous work is preserved. That's also what we ensure in the log directory tree. So we can always start where we left off. And we track also in the database where an upgrade had been left off. So standard upgrade is resumable as well. And here a quick example. I run deploy here. I upgrade a database. So let's check LSJ, DB12 gets upgraded here. And we wait a bit until we are here at 41%. Now we do something mean. We kill AutoUpgrade. Kill -9 on the job ID. You see it's killed. I'm back on the command prompt. No worries. You start AutoUpgrade with exact the same command. It detects where it has been stopped, and it goes on from there. It resumes. No extra action required. Very simple, very straightforward. But it could be even better. What you could do is use no-hub with -no console, or, and I like this idea quite a bit, you can use a terminal multiplexer. So if you are not aware what a terminal multiplexer is doing, it's basically creating a terminal session on the host as like an intermediate instance, like the man in the middle. And in that case, tmux, for instance, is a good one. You can download it from GitHub or install it as a standard package on your environments. And then you connect to the intermediate session and from there to the server. So if you reboot, if you go home, if your X-term, whatever, your VMware disappears on your local server, no worries. It's still running in the terminal multiplexer and you just reattach to it. So this is a pretty cool thing. And Daniel will tell you now more cool things. So Daniel, your turn.
What if a fix-up fails? First, you have to run AutoUpgrade in analyze mode. When AutoUpgrade analyzes your database, it'll create a checklist that is specific for your database and it contains the issues that is found in your database. The checklist is stored on disk. Find it and open it. You can then find all the fix-ups mentioned, and you can change the run fix attribute from yes to no if you don't want AutoUpgrade to run a specific fix-up. In this example, I've told AutoUpgrade that it shouldn't gather dictionary stats before the database upgrade. Then you edit your configuration file. You have to specify the location of the checklist that you just changed. Now, by default, AutoUpgrade will create a new configuration file for each run. So if you want to use the one that you already created, you have to specify it in the configuration file. Next, you run AutoUpgrade in deploy mode. It won't generate a new checklist because you specified an already existing checklist in your configuration file. So any offending fix-ups will no longer be executed. What if you need to restart? One of the good things about AutoUpgrade is that it can automatically flashback the database for you, even after a successful database upgrade. So if you have a test environment where you might want to repeat the same upgrade over and over and over, you can just use AutoUpgrade to flashback the database. Also, if you copied the data files before a plugin operation, you can also use AutoUpgrade to revert the plugin operation. On the command line, you start AutoUpgrade and you specify the restore option to do it. If you revert or restore the database in any other way than using AutoUpgrade, you have to tell AutoUpgrade what you did. Now, AutoUpgrade keeps track of what you are doing, what has happened to the database. So if you, behind the scenes, restore a database, for instance, using RMAN, AutoUpgrade will get very confused because now all of a sudden the database has been restored, but AutoUpgrade didn't do it. So to proceed from here, you have to clear the recovery data that AutoUpgrade stores on disk. You can clear recovery data just for one specific job, for one specific database. That's the little hammer. You can also use a bigger hammer to clear all recovery data for all the databases, for all the jobs that are stored in your configuration file. And if you want to use the really big hammer, the sledgehammer, you can remove the directories, the AutoUpgrade directories from disk entirely, which will clear out the recovery data that AutoUpgrade stores. You should only do that if the first two options doesn't work. And you'd need to do it by clearing the AutoUpgrade log directory and the log directory that is specific for the upgrade. For your reference, I have included a link here to this blog post, which has a little more details about what happens when you clear the recovery data. And what if you have TDE tablespace encryption? Well, if you want to do a non-CDB or CDB upgrade and you have an auto login key store, you're all good. You can simply upgrade the database with AutoUpgrade. Whereas if you want to do plugin operations or a non-CDB to PDB operation, and the source database, the source PDB is encrypted with TDE, you can't use AutoUpgrade at the moment. And the same goes with Unplug plug upgrades. That's currently not supported with TDE. But it's in the pipeline. We are really working on getting better integration or better support for TDE tablespace encryption. Some of the things that we are working on is support for key store external password store and some sort of mechanism so you can safely type in the key store password into the AutoUpgrade console. And we also would like to be able to handle situations better when you have a RAG environment or data guard.
And what if something goes deeply wrong? Don't cry, don't panic. AutoUpgrade -config -zip. It puts all log files together. It zips the entire log directory of AutoUpgrade, and you upload that to Oracle support. If AutoUpgrade tells you it couldn't find the alert log, add the alert log by yourself. And my recommendation, my personal recommendation, add an OPatch ls inventory just to avoid that extra question. Open a service request, set the severity correctly, and then please interact with Oracle support. We have created AutoUpgrade in a way that it tells us what it has done in the background. So we will always be able to find out if something has gone wrong, what has caused that. What if you want to change compatible? By default, all techniques we showed you today don't touch compatible. AutoUpgrade doesn't change compatible. There may be a parameter option in the future allowing you in a config file to decide that you want to change compatible, but by default, it's not changing. Neither does the DB upgrade or the DBOA. Our recommendation is change compatible if you are allowed to have that extra downtime, because a compatible change requires that you restart the database. Do it 7 to 10 days after the upgrade, because in that period, you can run the downgrade script. And the downgrade script doesn't work anymore when compatible has changed. Same applies, by the way, to the guaranteed restore point. This is why AutoUpgrade does not change compatible. It wouldn't work. When you have a GRP in place, you can't change compatible anymore since 12.201. When you change compatible, you have to restart the database, and please set compatible to the default value of your database version with 3 numbers. 1900 is the default. And never change it when you apply a release update. Or, wait a bit, we broke that rule. With 1910, we broke it. When you want to use blockchain tables in 1910, then you have to adjust compatible and you have to restart your database in order to be able to create a blockchain table in 1910. And that means you can't revert it. Be very careful with such changes. My recommendation is still never change compatible with an RU. The only exception from that rule I can tolerate is when you have all your 19 environments already on 1910, then it won't matter. But especially when you use multi-tenant, it would be a disaster if you have one CDB with compatible 1900 and one CDB with 1910. Because when you plug in now from the lower compatible to the higher, you get a secret compatible change and you can never plug back. So whatever you take from the 1910 one, you can't plug it into a compatible setting 1900 or 1910. This is why you should be really careful with that. And what if you want AutoUpgrade to do this right now for you? It's straightforward. We use techniques we talked about before. So you can't change compatible when the guaranteed restore point is in place. So the first thing is, when the upgrade is successful, we need to tell AutoUpgrade to remove the guaranteed restore point. This is done by drop GRP after upgrade, yes. And then I ask AutoUpgrade to call a shell script after the upgrade is finished successfully. So the after action shell script will only be called when the upgrade is successfully at the end of the entire process. I call my shell script here change compatible sh. And my shell script is very simple. It sets my environment. So the dot blank DB19 sets my 19C environment. This is just another shell script, which in my case is centrally on a machine in user local bin. But you can use whatever shell script to set your environment. And then I call SQL plus, and in SQL plus with slash, I call a SQL script. And that SQL script change compatible is on the slide here. So it connects slash the sysdba. It sets compatible 1900, scope SP file only, because you can't set it in the database right away. Then it shuts down, it starts up, and it exits. And this simple thing changes compatible when you used AutoUpgrade. So you see, you can do a lot of great things with these parameters in AutoUpgrade.
Now let's talk about diagnosability. In addition to the AutoUpgrade checks, it is also recommended to run the hchecks.sql script. It is a single package which looks for common data dictionary problems. The script checks consistency of selected dictionary relationships and looks for certain known issues. It is a lightweight read-only script which will not impact your data. Once it is run, it will produce a summary of the problems found as well as a severity, such as critical, fail, warn, or pass. To get more information and details, visit the most note listed on this slide. Now, going back into the AutoUpgrade, a good way to get information about the status of a job is through the AutoUpgrade command line. The LSJ will display a summary of the progress of all the jobs, which will give you an idea about how many stages are remaining. In addition to the LSJ command, we have the status command. It will give you all the information about a particular job, including specific details of the current checks, or fix-ups run, logs location, and so on. If you are running the AutoUpgrade in no console, you can get this information from the status and progress files, which we will see in a moment. Even though the AutoUpgrade has a powerful console that can be used to gather information of the jobs, this information can also be found in the log files. The AutoUpgrade separates the log files on different folders to isolate the information and make it easier to diagnose a given problem. For the following examples, we will consider that we are using this configuration file, which is a configuration file that will be upgrading two databases, a 11204 database called DB19c and an 18 version database, which is called CDB18x. This configuration file will produce two jobs, one for the 11204 and one for the 18. Notice that we have not specified the log directories for neither of the databases. This means that all the log files created will be under the AutoUpgrade log tier. An execution with this folder will create the following directory structure. The CFG tools folder will contain a log file with the overall information of the jobs, state, and progress files. Just as a side note, this folder belongs to the AutoUpgrade job manager. For every job, the AutoUpgrade will create a folder name with the SID of the database and a job number, also known as the job identifier. The most relevant folders for you are the pre-checks, DB19c, and temp directory folders. The folders that you will see depend on the execution mode the AutoUpgrade was run with. This is because each folder belongs to a particular stage. As you see, if you run the analyze mode, you will see only the pre-checks folder. If you, on the other hand, run the fix-ups mode, you will find the pre-checks and prefix-ups. And if you run the deploy mode, you will have one folder for every stage that the deploy mode runs. We also should keep in mind that with every execution, the job number will increase. This helps us to isolate the log files from previous execution and do not mix the content. So this means that for this configuration file, if we run the analyze, then we run the fix-ups, and then we run a deploy, we will end up having this structure. So we will have 6 folders, one created for every job execution, and because we have 2 databases in this configuration file. If we want to list the reports created during the analyze phase for the CDB18x, we will need to go to the job ID 100 and then go into the pre-checks folder. And we will find something like this. So we have a few files there, but the most relevant files for us are the preupgrade.html file and the preupgrade.log file. These files are the reports created for the user, and there you will find a summary of the conditions that were found on your database and see if we can fix them or not. On the other hand, if you want to customize the execution of these fix-ups, you can use the checklist.cfg file. And using this file, you can choose whether you want to skip a given check or fix-up or just skip the fix-up for this. And you can do so by modifying it and changing the content of the run fix tag by inside of chest to know if you just want to skip the fix-up. And if you want to skip totally the check and the fix-up, you can use the underscore skip tag. Once you have done this, you just need to add the checklist option into the configuration file and add the pointer to the checklist file that you just edited. If, on the other hand, you are interested in to get more details about the actual content of the upgrade logs, we will need to visit the job ID 104 because that's the job ID that belongs to the deploy of the CDB18x. If we go into this folder, we will find the log files produced by catctl and catcon. And well, there also you will find the summary of the upgrade. The content of the general progress folder can be seen into three major groups. The log files that belong to the job manager, as we described before. The files and folders that contain information of the AutoUpgrade, such as the control files and the state files, and the status files. On the control files and the state files, you will find some binary files that are created by the AutoUpgrade that contain specific information about the current environment and also the current state of the AutoUpgrade. This is that if we face a given problem and the process dies, when you resume the AutoUpgrade, we will read the information from these files and we will start from where we left before. That's why it's very important that these files shouldn't be modified by the user, as these are very important files that are only for internal usage of the AutoUpgrade. On the last section, for the status files, we have two major files. One is the state.html file, which is a file that we have a summary of every step that was run by the AutoUpgrade and that can be used and consumed by you if you want to read on human readable text what's going on the tool. On the other part, the status folder will contain some JSON files that we have the progress.json and the status.json file, which are files meant to be consumed by other tools, just in case that you want to integrate the AutoUpgrade into your own pipeline and automate it. These files get produced even if you choose to run with console mode, so that if you run with console or no console, you can still get information from these two files. Another interesting directory is the temp directory folder. The temp directory folder is the place where the AutoUpgrade will save some files that are created or modified by it. In this directory, you will find the before, during, and after upgrade files that are created by the AutoUpgrade. And also, you will find some files that are created during the process of the upgrade, like the recompilation scripts and restart scripts. One very important part of this folder is that whenever the AutoUpgrade modifies a database file, such as the network files, when it is merging the content of them, we will create a backup of every file that we touch. And also, if we are working on RAG, we will create a backup of every file of every node that we touch. So you will be able to find backups for the TNS names, listener, SQLnet, and also other files. In addition to this, you will also be able to find some log files, like the timezone upgrade log directory, and some context files, which are just a list of files that we copy from source to target for the context component of the database. How to know if something really bad happened? Well, the AutoUpgrade has three ways to provide such information for the user. We have the console, the status files, and the log files. One of the most easiest ways to find out if something bad happened during your upgrade is checking out the AutoUpgrade console. If the AutoUpgrade faces a problem that it is not able to automatically fix, it will emit you a message like this. It will contain you the stage where the problem occurred, and some additional information, such as if there is an error code available, and also where you can find more details, which is a pointer to a log file. In addition to the console, we also have the status.json and progress.json files. These files are under the status folder. These files come into a more friendly way in case that you want to add this into your own pipeline. And in these files, you will be able to find the details about what went wrong, and also to see if there is a manual action expected from your side. Last but not least important, we have the log files. The log files are pretty much the source of truth. So on every execution of the AutoUpgrade and for every job, you will be able to find an AutoUpgrade_error.log file. If this file is different from 0, it's worth take a look into it, because you might find something that occurred. Into this file, you will be able to find from a small warning that says that something was not properly parsed until a given stack trace that something really bad happened because the AutoUpgrade wasn't able to handle it.
Wow, that's really a lot of log files. But I must say they do come in handy when there is something that doesn't work as it should. We really went over a lot today, and I hope that you learned a lot of new features that you can try out in your own environment. And remember, if something goes south, you can use the restore option in AutoUpgrade to flashback your database. If you copied the data files during a plugin operation, you can even revert the plugin operation also using AutoUpgrade. And after that, you can use the zip option to create a package which contains all those log files and configuration file. You add the alert log and then send it to us so we can debug your issue. So give it a try and good luck.
That's it for today. We hope that you enjoyed it and learned a lot.
We are really looking forward to see you in our next virtual classroom seminar. Next topic will be performance testing.
Thank you. Take care and happy upgrading.